Hello learners, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently, I'm a mathematics teacher. Now let's see how to prove the given theorem. Now what does this theorem state? This theorem states that let f maps A to B be a function. Then f is a bijection if and only if there exists a function g maps B to A such that f circle g equal to IB and g circle f is equal to IA, and in this case g equal to f inverse. Pretty complicated, right? You can't make out what is going on in the first reading, right? To get its solution, it took me some good amount of effort, so please stay with me. You'll have a good time understanding this. Okay, now what does this mean? This actually the most important is if and only if there exists a function. Understand, if and only if there exists function. This means that if they're asking us to prove two things. Like, let's say if there is a function such that g equal to f inverse, then f circle g equal to IB and g circle f is equal to IA. Fine, that is the first thing they're asking to prove. In short, I'm telling, the first thing they're asking us to prove is if f maps A to B is a function, and then if f is a bijection and g equal to f inverse, then f circle g equal to IB and g circle f is equal to IA. This is the first part which I need to prove. The next part which I need to prove is if it is given that there exists a function g such that g maps B to A, that function is such that f circle g equal to IB and g circle f equal to IB. Then I need to show that g equal to f. And you might not be able to figure out what's going on. I know it's a bit difficult, but yeah, let's proceed with the proof. Okay, fine. Now what we are given here, we are given just one thing. If f maps B to B is a function, this is the only data we are given. Now next, what we need to prove, that we need to show that f maps A to B is f is a bijection. Now this should give you a little bit better understanding. F is a bijection if and only if there exists a function. Okay, it's actually the same thing. I copy pasted it. Fine. If as I go through the proof, I hope you guys could get it. Now, first I'm going to take that g equal to f inverse. And I'm going to show that f circle g equal to IB and g circle f is equal to IA. This is the first part of the proof. Fine. Now, okay, fine. If I'm going to take that f is a bijection and g is equal to f inverse. Okay, then I'm going to show that f circle g equal to IB and g circle f equal to IA. Now, first things first, let f maps A to B is a bijection. This is my assumption. Now, based on this theorem, I can show that I can take that if f maps A to B is a bijection, that means g is f inverse based on this theorem. I'm taking like that, and I'm going to show that what I need to show. Now next, since f maps A to B is a bijection, f inverse maps B to is a bijection. If a function is a bijection, then its inverse is also a bijection. Okay. Now next, if I'll take g, I'm going to take g as f inverse. Now next, now one theorem, the fourth theorem, the fourth important theorem, I would say, in that that if f maps A to B is a bijection, then f circle f inverse equal to IB and f inverse circle f is equal to IA. Okay. In fact, this was the third theorem. I'm sorry. In my one of the important theorems. Fine. If you want proof for this theorem, you can just check out the playlist. I'll put the link for the playlist in the description. There you'll find the proof for this theorem. Well, now you not have to write the proof for this theorem here. Now, yes, if f maps A to B is a bijection, there's a previous theorem, and I'm using its result here. Okay, then f circle f inverse is equal to IB and f inverse circle f is equal to IA. Next, what did I take g as? F inverse. Okay, so wherever you see f inverse, instead of that, write down g. So f circle g equal to IB and g circle f is equal to IA. That's it. First part of the proof is done. Actually, first part is pretty easy and simple also. The harsh part is the second part, wherein another two theorems would be used, which their results would be used, which I'm going to state them here. So don't worry. If you want their proofs, I have not made any videos. You can just refer textbook. I'll give the theorem number there. Now next, the next thing what I'm taking is, let there exist a function g maps B to A such that f circle g equal to IB and g circle f is equal to IA. If this is the case, what I need to prove is, I need to actually prove two things. I said only one thing here. You need to show that g is equal to f inverse and f is a bijection. I need to prove two things. If I take this set, if g maps B to A is a function such that f circle g equal to IB and g circle f is equal to IA, then there are two things which I need to prove. What are the two things? The first thing is that f is a bijection, and the next thing is that g is equal to f inverse. Fine, this is what I need to show. Let's get started. Now, if you guys will observe, G circle F is equal to what? IA. G circle F is equal to what? IA. What is IA? IA is a bijection, right? Identity function is a bijection. Since it is a bijection, it is a injection also, a one function also, right? Since IA is an injection, now G circle F is equal to IA, right? So G circle F is also an injection. Fine. Now I have two functions f and g such that G circle F is an injection. I have two functions f and g such that G circle F is an injection. This is a theorem. Okay, this is a theorem. What does that theorem states? If f maps a to b and g maps b to c, basically f and g are two functions such that G circle F is an injection, then f is an injection. Fine. Now here what I got, here f and g are two functions. F and g are two functions. Means g is there, f is also there, right? F and g are two functions such that G circle F is an injection. Same thing. This theorem statements if G circle F is an injection, F is an injection. Previously also I got, since G circle F is an injection, therefore f is an injection. Now this is what I wanted to say. Since f maps a to b, now this is our scenario. It's a theorem and this is our scenario. Since f maps a to b and g maps b to a are such that G circle F is an injection. Like if G circle F is an injection, then f is an injection. The second function is an injection. G circle F, G and F, like that. G circle F, so G and F. That's why f is an injection. Fine. Using that theorem, I showed that f is an injection. Now next, I know this things could go above your head. You could watch this video over and over, or if you have any doubts, post it in the comment box. I'll try to reply. Okay. Now next, if you guys remember, I got f circle g is equal to ib. F circle g equal to ib. Now ib is an identity function. Same logic. Ib is an identity function. An identity function is a bijection. Since it is a bijection, it is a surjection also, right? Now, therefore, f circle g is equal to ib. So, therefore, it is also a surjection. Logic in this question. Now, since ib is a surjection, therefore, f circle g is a surjection. Now, another theorem. What does this theorem state that? I have given the reference number, okay, theorem 1.2.8 and from theorem 1.2. You can refer to it in the textbook. If f maps a to b and g maps b to c are two functions such that G circle F is a surjection, then G is a surjection. Right? Means the first function will become a surjection if f and g are two functions. Next. Now here, let's come to our case. Here we have two functions such that f circle g is a surjection. Circle is in this, the first function is what? F. So if I'll apply this theorem here, so my g will not be a surjection. Don't go by names. Here my first function is g. Here my first function is f. So therefore my f will be a surjection. My f will be a surjection. Now, I previously showed that f is an injection, and now I'm showing that f is a surjection. Since f is an injection and a surjection, therefore f is a bijection. So f maps a to b is a bijection. Hence, f inverse maps b to a is also a bijection. If f is a bijection, then f inverse is also bijection. Next, also one more thing. If you'll see here, g maps b to a. Therefore, f inverse and g are defined on the same domain, capital B. Their domain is totally same. Now next, let me take out an element. Okay. Now since f maps a to b is a bijection, in fact it's a surjection also. So since it's a surjection, if I'll take an element b which belongs to capital B, then there must exist an a belongs to capital A such that f of a equal to b. Right. Now I'm going to input. Now since f of a equal to b, f inverse b equal to a. Like if you send this f here, sort of, you can think like that, although it's not the case. You can just remember it like this: f inverse b equal to a. Next, now I'm going to start out with this. F inverse b is nothing but equal to a. F inverse b is nothing but equal to a. Now listen to me carefully. This is a crucial part. This a I can write it as ia of a. This a I can write it as ia of a. Why? Ia is an identity function. Whatever you'll give input to this will give the same thing back. So that's why I can write a as capital IA of a. That's totally fine. Let's move forward. Now, what is this IA? If you guys remember what is this IA? It's nothing but G circle F. If you just go back a little, you can just, I took G such that G circle F equal to IA and F circle G equal to IB. So that's why I can take IA as G circle. Now G circle F of a I can write as G of F of a, the basic fundamental of it, of functions. Now next, what is F of a? It's nothing but B. Fine. Ultimately, F inverse of B is nothing but G. It's nothing but pointing to G. It's nothing but pointing to G of B. So you can basically, I'm basically saying that F inverse and G have the same domain, and they are mapping to the same element also. Like F inverse and G, if I'll give them some input, they are mapping to the same element. If that is the case, then the two functions are equal. Therefore, G equal to F inverse. And with that, this theorem is over. I know it could have gone above your head, even it had gone above my head for quite some time. I had to refer the previous theorems and like, oh, okay, this is like this, so this is like this. So since this is like this, that like it took me some good amount of effort into understanding this. I hope I could make it clear to you at least to some extent, even though I'm pretty sure that most of you may not be able to get how this works, but at least you can, if in fact, if you're finding it difficult, you can just mug up the solution and write it in the exam. That's also one of the ways. And I've given sufficient justification, I feel, to this video. And not just this theorem, I've made other theorems as well related to functions. You will be able to find the link for the playlist in the description. Fine. And if you like this video solution, in fact, I put in a lot of effort too, please hit the like button. And if this is your first time coming across to my channel, please do subscribe to it. Once again, I'm Akash. I completed my BTech from NIT Rourkela in the year 2020. Currently, I'm a mathematics teacher.